Hi everybody, welcome to Moniverse. In this video, we are going to see about the shortest job first scheduling algorithm. So let us get into the video. So what is shortest job first? Usually when the jobs are entering into the ready queue at time t, the smallest job, that is the job having the smallest execution time, will be taken for execution into the processor. So this is called as shortest job first. The shortest means that the job having the smallest execution time will be taken for execution. So this can be a preemptive or a non-preemptive. So preemptive, when it is coming to preemptive, it is this algorithm can be named as shortest remaining job first. So when it comes to preemptive, this algorithm will be named as shortest remaining job first. And the advantage of this particular algorithm, it is having the minimum average waiting time among all the scheduling algorithms in the operating system. But the problem is, in case if it is in the ready queue, continuously the shortest jobs are arriving, the longest job will not be getting the time or will not be getting the opportunity to get executed. So these longest jobs will be starving for a long time without being executed. This is one of the disadvantage of the shortest job first execution. So we can see an example for this shortest job first. We can consider the scenario that all the processes P1, P2, P3, everyone are arriving at the same time T. So everyone will be entering into the job queue. So now by finding the shortest job among P1, P2, P3 and P4, we find that P3 is having the shortest job, that is with a burst time 4. So with the shortest time of 4 as the burst time by the processor P3, P3 enters into the processor for execution. So now let us consider the Gantt chart too. As the execution or the burst time is 4, the process P3 will be executed for the 4 units of time. So I'm filling in the Gantt chart too. And after the completion of the 4 unit of time, now we are going for checking the table. There we find process P1 and P4 with the same execution of time 6. So what we have to do is we have to see which job arrives first in the queue. That is P1 is first in the ready queue. So what we are going to do is we are going to execute this P1. So P3 leaves the processor and P1 enters into the processor. Now, as the time of execution for P1 is 6, it has been executed for 6 unit of time. So I have specified this in the Gantt chart. Once the execution time of 6 unit has been completed in the processor, the P1 will be arriving outside. So at that time, the next this has been P3 has been executed, P1 has been executed, and now among P2 and P4, P4 is having the shortest remaining time. So now P4 enters into the processor for execution. So as this is shortest job first and this is non-preemptive, this 6 unit of time will be executed and it is put in the Gantt chart. So now after the 6 unit of time, this P4 also leaves the processor and we find that only one is left out, that is P2 with the execution time of 10 units. So P2 finally enters into the processor and P2 has been marked in the Gantt chart. So this is the final Gantt chart, what we have generated while we are executing the process P1, P2, P3 and P4. And from this Gantt chart, we are going to calculate the various time, that is turnaround time, completion time, and waiting time. As we have seen all the formulas, completion time will be marked from the Gantt chart when it is being completed. So first for P1, P1 has completed at time 10. So I have noted here as 10. And coming to P2, P2 has completed at 26. So I have noted here as 26. And P3 has completed, is the shortest job. So it has been um, taken into the processor at the very first time. So it has been executed and completed at the fourth unit of time. So I have specified here as 4. And for P4, it has been completed at 16th unit of time. So I have written here as 16. So now to calculate the turnaround time, the formula is completion time minus the arrival time. So completion time is 10, the arrival time is 0. So 10 minus 0, it is 10. So since all the process arrive at the same time at t is equal to 0, the exact completion time will be coming as the turnaround time. And I'm going to calculate the average turnaround time. I'm going to add everyone and divide it by 4 as total number of processes or 4. So 10 plus 26, 36, and 36 plus 4, 40, and 56. So 56 divided by 4, the answer is 14. Now to calculate the waiting time, the formula is turnaround time minus the burst time. So turnaround time we have calculated here and the burst time remains in this column. So 10 minus 6, it is 4, and 26 minus 10, it is 16, and 4 minus 4, it is 0. So 16 minus 6, it is 10. So we have calculated all the waiting time and now we have to calculate the average. 10 plus 16, 26, 26 plus 4, it is 28, 28 divided by 4, the answer is 7.5. So in the second scenario, we are going to consider the processes arriving at different time and it is non-preemptive. Non-preemptive in the sense the process currently executing in the processor will not be stopped by the process which is entering into the ready queue with its priorities. Okay. So if you have doubts in preemptive and non-preemptive, in the same operating system playlist, I have given the differentiation between the preemptive and non-preemptive. You can see the video. So now, so let us see at time 0, the process P1 arrives into the ready queue with a burst time of 6 units. So now the processor is being idle and the process P1 enters into the processor. And it is being executed for 4 units of time. At that time, another one process P3 enters into the ready queue. So now with this P3, as it is a non-preemptive, the P1 is not going to leave the processor. It is going to continue its execution because only 4 units of time it has spent the execution time in the processor. So minus 4, so remaining 2 units of time is left over. So we are going to complete that 2 units of time. Now the execution time of P1 has been completed. That is 6 units of time has been completed here. So the P1 exits the processor. So now at time 4, we have two processes entering P2 and P3. So P3 is having the shortest burst time. So as it is the shortest job first algorithm, now the P3 will be entering into the job queue. Okay. So P3 is having lesser time. So P3 is entering into the processor. So P3, the execution time of P3 is 4 units of time. So it will be executed now. So at the 8th unit of time, another one process P4, 8th unit of time, another one process P4 is entering into the queue. as it is non-preemptive, we are not going to disturb the process which is inside the processor, that is the P3 process. Okay, so it is being executed for 2 more unit of time. So with this, we have completed the execution of P3. So it leaves the processor. So now at the time T is equal to 10, we are having two processes P2 and P4, among which having the burst time 10 and 3. So in this, P4 is having lesser burst time. So now P4 enters into the processor for execution, and it is being executed for 3 unit of time. Once its execution time is over, it leaves the processor. Now P2 is which is the one and only process remaining in the queue. P2 enters into the processor for execution. As its burst time is 10 unit of time, it is going to be executed for the 10 unit of time. So as we have imagined how the things are being executed, we have generated the Gantt chart also. So now we are going to calculate. So it is very necessary that we have to be very careful on drawing the Gantt chart. Once the Gantt chart is completely ready with the exact notifications of when the process has been completed, we can easily calculate the turnaround time, completion time, and the waiting time. So here for complete for the sorry for the completion time, we have to just look on to the Gantt chart. For the process P1, it has been completed as the 6th unit of time. So I am specifying here as 6. And for P2, it has been completed as 23rd unit of time. So I have specified this as 23. And for P3, it is 10. And for P4, it is 13. So I have calculated the completion time from the Gantt chart. Now I'm going to calculate turnaround time using the formula CT, that is the completion time minus the arrival time. So here is the completion time and the arrival time is here. So 6 minus 0 is 6. 23 minus 4. The arrival time is 4. It is 19. And 10 minus 4 is 6. And 13 minus 8 is 5. So we have calculated the turnaround time. Now add everything and divide by 4, as we are having 4 processes here. So the average turnaround time for this one is 9 unit of time. And now to calculate the waiting time, we are going to calculate using the formula turnaround time minus the burst time. So turnaround time we have calculated in the previous section. So 6 minus the burst time is available in this column. So 6 minus 6, it is 0. And for calculating for the process P2, it is 19 minus 10, it's 9. And for process P3, 6 minus 4, it is 2. And for process P4, 5 minus 3, it is 2. So now to calculate the average time divided by 4. So sum up all these values, 9 plus 2 plus 2. 11 plus 2 is 13, right? So 13 divided by 4, it is 3.25. So we have calculated this. Hope you all would have understood what is shortest job first. So now we have seen shortest job first with different arrival time and the same arrival time, more or less, as it is a non-preemptive. This shortest job first process remains the same for both the same arrival time process and also the different arrival time process. So we don't have much differences, or we don't have any differences between the non-preemptive shortest job first, different arrival time and same arrival time. So in the next video, we can see the shortest job first with preemptive, that is shortest remaining job first. We'll be calling the algorithm as shortest remaining job first, that is SRJF. We can see that in the next video. So thanks for watching. Hope you all should have understood what is the SJF CPU scheduling algorithm. For more such videos, please subscribe and stay tuned to my channel. Thank you. Bye.